Hi everyone, and this is the acid-base solutions reaction lab video. So the materials you're gonna need for this lab, you're gonna need your baking soda, you're gonna need your vinegar, you're gonna need some water. You will need graduated cylinder, the small one, 10 milliliter one is fine. And you'll need 3 small cups. So you can use little condiment cups, little Dixie cups. You want them to be small, smallish. And you're also going to need your digital scale and a piece of scrap paper to use as a piece of weigh paper. So you're going to want to label these cups. You can do that either drawing on the cups themselves, or you could put them on a piece of paper that you label A, B, C. All right, in cup A, it tells you to add 10 milliliters of your vinegar. So you'll just pour the vinegar directly into the 10 milliliter graduated cylinder, exactly up to that 10 milliliter line where you can read it at eye level. You'll add that to cup A. Cup B, it says to add 10 milliliters of water. Make sure, you might want to add the water to the 2 cups to B and C first and then add the vinegar. If you add the vinegar first, just make sure that you rinse out your graduated cylinder well so that it's not contaminated with vinegar, so that you're not accidentally contaminating the other 2 cups. So vinegar, 10 milliliters of vinegar, 10 milliliters of water in each of these. And then in cup C, you're also going to add 1 gram of your baking soda. So just a reminder, when you're using the scale, make sure that it's on a flat surface. And you should turn it on, wait for it to read 0. And then put your scrap of paper on the weighing tray, or the weighing, the metal weighing part, and hit the T button. T stands for tare, and that'll make the scale go back to 0. Also make sure that it is in grams, that it is reading in grams. If not, hit the M button to switch it to the unit of grams. And then you will just use a little spoon or something to scoop out and weigh out 1 gram of your baking soda. And you will add that just by taking your paper carefully and dumping it into cup C. Then you're going to want to stir it really well. Baking soda is not super soluble, so you'll want to stir it really well. It also might start to look a little bit bubbly because the baking soda will start to form a little bit of carbon dioxide in solution. The next thing you're going to need is your pH strips. So this comes in a little booklet, kind of like a match booklet. And if you open it up, there are these little strips of paper in here. And so you can tear them off. These papers have been soaked in a pH indicator. So that is a dye that changes colors under different pHs. So you can dip the strip into the solution and then compare it to this chart here to determine what the pH of the solution is. So the easy peasy way to do this is just take your strip, dip it in, and then lay it across sort of the mouth of the cups. And I think I've mixed up my ABCDs here. So you just dip them, and then you can lay them across here. Then you can take a nice picture for your photos, and you can also easily go across with your chart here and compare the strip, the color change, to the colors here, and line it up to pick the best pH, estimate the pH to the best of your ability. If you don't have the best eyes for judging color, bring in an assistant, ask a kid to help you get a second opinion from another house member or stranger on the street, whatever, in order to ensure that you're getting a good reading. You do want to do this relatively immediately, so don't walk away and come back 30 minutes later and take the reading. The color changes a little bit over time, so do it within a minute or so of having dipped it in the solution. All right, so you're going to be doing that. You're also going to, the second part of the lab asks you to mix 2 of the solutions together, and there will be a fizzing reaction. All right, this is, spoiler alert, it's going to be an acid-base reaction, and but it happens to also be one that produces carbon dioxide. And so you'll want to do it slowly, because you can see it fizzes. So do it a little bit at a time. We don't want to get an overflow, but you do want to mix them entirely together. And it'll keep reacting and keep forming carbon dioxide bubbles. And the best way to actually mix it, I got a little bit, oh, it was a good save. All right, just mix them back and forth until it stops fizzing, until the reaction is completed, if you will. And the carbon dioxide can escape a little bit. This is just helping the carbon dioxide bubbles escape, flattening the solution, if you will. That's fine, there's still some carbon dioxide bubbles in there. And then you're going to take a pH reading of this. Before you do that, pause and think about, what do you think the pH will be? What happens when we mix an acid and a base together? And make some predictions, and then you'll do your little dip test and see if your prediction comes true. So then I'll want you to write what your new pH is, what you identify the new pH to be, and why. Explain it, using chemistry to explain why that is the new pH. And that is essentially the acid-base experiment. Oh, no, that's not it. So then in that mixing reaction, I also ask you to use some candies to make diagrams of the molecules. So we have acetic acid, which is CH2, it's CH3. So I'm gonna do CH3. I've got some yellow candies for hydrogens and blue candies for carbons. All right. And so that's CH3, and then it's COOH. I'm using red for my oxygens and yellow for my hydrogens. So that would be an example of an M&M model of acetic acid, CH3COOH. All right. When we dissolve this in water, in molecule, it loses an acid and it loses a hydrogen. So it becomes acetate and a proton, hydrogen, H+. We could do the same for the baking soda. Baking soda is sodium. I'm going to use green for that. Hydrogen, carbon, 3 oxygens, CO3. Ta-da! All right. When we combine these two, all right, I'm going to do it like this. Okay, so here's the baking soda and the vinegar. All right, we lose H, these two H's come off, and an O, so now we have H2O. All right, this sodium attaches right here. So now we have sodium acetate, water, and CO2, carbon dioxide. Those are the products. So you can see that conservation of mass, how the atoms are simply recombining to form the products. We didn't, pull any other types of atoms out of thin air. And we could make it go back in reverse if we wanted to, like so. All right, so practicing with those manipulatives really can help cement that concept into your mind of how this works. So do it with some candies or some cereals, and then draw it in the lab with some markers or colored pencils or something, okay? And that's the lab.